Greetings, everybody. Haven't done a video in a while. Practice exam question, double replacement. We're supposed to give a complete balanced double replacement reaction for the reaction between strontium nitrate and rubidium sulfate. Talk to me about what I'm doing right now. SR 2 plus NO3 minus RB plus. How am I doing this? Is it magic? SO4 2 minus. I just used the words that are in the question, didn't I? Ions. Don't skip this step. Need this step. Those that try to skip this step are trying to balance before they should balance, and they don't get it right. They get everything wrong. So strontium nitrate, just cross them over and get a balanced formula for me. What's the strontium nitrate formula? SR parenthesis NO3 twice, and the state. Wait, this is one it'll say on the question, include states. Control T. Include states. Question, exclamation. Okay. Okay. So what is the state? It's actually told in the question. AQ. It's a reactant. And crossover RB and SO4 2 minus. What do you get? RB2, SO4. Oh, no, parentheses, because there's only one of them, right? SO4, and it's also AQ, no? Yeah. This thing's up here. Okay. I don't know what happened there. Why are you being mean? My computer's being very mean. Okay. I don't know. Meeting chat. No, thank you. Okay. Next up, products. Cross them over to get the other anion cation combination. Can't see everything on the screen. Move it down. There you go. All your ions again. You need them again. Strontium ends up with what when you're done? How'd you know that? That's good. Well, why didn't you cross strontium with rubidium? I need cation anion. Yes. SrSO4. How come it's just one of each now? The 2 and the 2 cross over, and then you simplify. That cancels out. Exactly. And what about the other product? It's got nitrate in it, so I know I'm going to put AQ, RbNO3, AQ. We need the practice exam to figure out if strontium sulfate is a precipitate. Yeah, it is. I'm going to get that practice. Test 3, useful information, right? See if I can find. Oh, I closed it. Yeah, it is. I think you're right. Useful information, test 3. Why not? Here it is. You ready? Oh, no, it's too small. Rotate clockwise. Rotate counterclockwise twice. Oh, it's upside down. Let's read upside down. SO4 2 minus is always soluble except when it's with strontium. That's a precipitate. Sorry about the upside downness of the situation. I don't think you saw in the video what I just did. I didn't switch screens. I went to the solubility rules. I verbally said them. That makes strontium. The guys is getting very noisy in here. I'm having trouble following my own lecture. That's not good. You are contributing to the decline of the content of the material by making all that racket. Okay. So what about balancing? Because now it's time. We have all the states. We have the right formulas. This is the only time to start balancing. Don't think you've invented the other way, because you haven't. All right. That will be a quote on your exam being graded if you think you have found the other way. No, nobody has still found the other way. It's going to be on. No, I'm not going to do that. That's sort of sarcastic. Let's not do that. So now we balance. Strontiums look good, don't they? Nitrates don't look so good. NO3s. What's the quick fix? Put a 2 in front of which one? RbNO3. And does that finish everything? It does. The two rubidiums also fix the two nitrates. We win. No, we were doing the nitrates. It also fixed the two rubidiums, whichever way you want to talk about it. So nice. Give complete ionic equation. Oh. Hey, if it says AQ, I want you to break it down to its ions. So how does this break down to its ions? There's one of them. So how many strontium ions do you get when it breaks down to its ions? One gets one. So this is the complete ionic. This was the balanced part A. So SR, whoa, why? You don't need a 1. But you need to tell me it's dissolved in water. Basically, I'm restating the original balanced equation. How many nitrates are in that one molecule? So 2 NO3s. The 2 ends up there. And it's dissolved in water. And rubidium's dissolved in water. And how many of them are there? Yes, so it's aqueous, I agree. It's +1. Oops, my bad. It's not +2. There's 2 in front. Do not, guys, do this and you're in trouble. Do that, you're done. Don't do that. It's breaking up to its ions. It's 2 rubidium plus ions. There. Got it? And how many sulfate ions? Just look at it. There's one molecule, and the one molecule has 1 sulfate. And guys, I messed up on the rubidium. I forgot to say its state. What's the state? It's right upstairs. So basically, this is a more realistic representation of the reactants. Break it up to the ions. It tells you how many nitrates. It tells you how many strontiums. It tells you how many rubidiums. 2. How many sulfates? 1. Now, this is not dissolved in a precipitate is a precipitate is a precipitate. You write it as a precipitate. It's not ionic anymore. So you write SR, SO4. I need a reaction arrow. If the ion had a subscript, then it ends up being a coefficient. Yeah, down here. Yes. Her question was, if the ion had a subscript here, does it end up as a coefficient here? And the answer is yes. And we are making strontium sulfate, and it's a solid, so it is not broken up to its ions, but this is ionic, broken up to ions. How many rubidiums? 2 rubidiums. You can check your work. If you did your work properly, balanced before is balanced again. All right. How many nitrates when you're done here? 2 molecules. Each molecule has 1 nitrate. 2 nitrates. All right. 2, not 3. I don't know what I'm doing. There. 2. There. And how do you say it's dissolved in water? Yay. AQ. So your complete ionic is there. It's got all the ions that started and all the ions that ended and the precipitate. The easiest part, if you've done that properly, is now the net ionic. I only want the ions that contributed to making the precipitate. So look, guys, I would do part C like this. Copy the precipitate as a product. Just copy it. Copy it. What ion gives SR? Look over here. Which ion has SR? That's the one. Copy it. Tell me it's dissolved in water. What other ion contributed to making the precipitate? SO4 2 minus. Copy it from the previous line. What got left? What got canceled on the previous one? Strontium didn't get canceled. Nitrate did. Look, 2 nitrates became 2 nitrates. Did it change? Was there a net change when 2 nitrates goes to 2 nitrates? No, net change means tell me what parts changed. So yeah, don't put nitrate, it didn't change. How about the sulfate? It changed. It went from being dissolved to being part of a precipitate. Rubidium, not the same. Rubidium disappears, right? Why? 2 rubidium ions became 2 rubidium ions. End of story. Good. So net, just zoom in on the precipitate. Give me the ions that made the precipitate. You don't have to underline them. That just happened. D. You only look at the precipitate and give me the ions that made it. There's only one precipitate on the whole page. It has S. Precipitate has S. I only need the ions that make the precipitate. Do not copy any other ions because they didn't do anything. They sat around and watched. We have a name for that. Some of you are probably reading. They're called spectator ions. I'm not going to ask about them, but we got rid of the spectators in that last step, didn't we? They were just looking at things and they didn't do anything. And D is, how do you know finally you're going to need some kind of a molecular weight? Once you see the word moles and a number, you're going to need a molecular weight for whatever they're talking about right there. So I only want the molecular weight for SrNO3 taken twice. SR, strontium, Kasarbara, right there, 87.62. Do you want to hear about a rookie mistake that a lot of first-time chemistry students make here? They start using the coefficients for molecular weights. What's the one sentence you tell those students so that they don't ever do that again? Coefficients are only used to go from moles of one substance to moles of another. Is this question asking you to do that? No, we went. Well, it is. Moles of strontium nitrate, excess, how many moles of precipitate can be formed, but they're different substances, right? Not yet, not now. But I'm just realizing, what is molecular weight for again? To go from moles to grams or grams to moles. And we need moles to talk about the equation, right? They gave us moles. Here's my comment. My comment. If you already have moles, not needed. We have moles already. We have moles already. If you're given grams, you need the formula weight. So I'm going to write that down. It is when you are given grams and a formula that you need molecular weight. Control T. It is when you are given grams and you need moles that you use the molecular weight. And we'll make that bold and orange for caution and move it down. Good, there you go. So we already have moles, and it says 0.1234 moles. Hey, you got moles of one substance. What can you do right away? To moles of another substance. You better keep track of what substance you're talking about, or you won't go anywhere. Once you have moles, you can go to moles of something else. And what's the something else we care about in this question? Precipitate. And you identified that as strontium sulfate. Oh, is the word rubidium lurking anywhere in here by mistake? Yes. Strontium. What did we get rid of rubidium and replace it with? Strontium and rubidium. Oh, it's there. Nitrate and sulfate. Good. Strontium sulfate. Strontium sulfate's not a reactant. Strontium nitrate and rubidium. Yeah, rubidium sulfate. Good. Excess rubidium sulfate. Strontium nitrate. Good. We're fine. I don't know why I'm confused. We have to go to the precipitate, which is this. And then Jacob, just a reminder. PPT, right? Okay. So I need the relationship between moles PPT, and moles of SrNO. We got to get rid of SrNO3 twice. And what is the relationship? Moles and moles are between balanced molecules in the equation. One of the SrNO3s gives one of the precipitates. Do you agree? I need to see the ones. And the question's asking for moles. And we'll be done. Correct? Yes. What are these numbers called again? I like reminding you. The 1 and the 1. What are those numbers called? Coefficients. And we're using them for the only purpose we're supposed to use them for right now. You started with moles of this substance. The question wants to know about the moles of the precipitate. That's a different substance, A and B, right? And the answer is 0.1234. Moles. And the precipitate is SrSO4. Big S, little r, SO4. And that's the end of that. I assume they're going to give us some weight or something in part E. Yes, E. Yes, 6.524. 543. I didn't hear it right. 543. Oh boy. Grams SrSO3 is the SO4, right? SO4 is the blank yield. Give me the right blank. Look at the words in part E, please. It's going to be there. If you think part E is giving you the theoretical yield, you're not reading. Actual and theoretical are different things. So actual yield is what we're working on right now. Actual yield. And the theoretical yield is 0.1234 moles. You can't compare moles and grams. I can compare moles to moles or grams to grams and get the same answer in this question. Look at the study exam when you get the key on Saturday. It says this 3 times. You could have done grams per grams here instead of moles per mole. And then in the next time I do it, you could have done moles per mole instead of grams per gram. And they work, but you got to convert one of these two things. You pick. Do you want to convert the moles up here in green to grams? Or do you want to convert the grams here to moles? Either way, you're going to need the formula weight of something. And what is that something? This is where you need a formula weight. Strontium hits you for 87.62. Sulfur 3207. 4 oxygens, 16 each. So we get 64, 96.07, 96.071, 83.69. I need that verified. I'm just doing this to try to keep away the old cobwebs from old age, okay? That's why I'm doing estimations as we go, and half the time they're wrong. No, you must use the molar mass of only that chemical. It's the only relevant molar mass for this question because we have moles of it and we have grams of it in another part, and we better use the right formula. Okay, it worked out. Nice. So you want to get the grams to be moles? It doesn't matter. They're both good. 6.543 Grams times something that gets rid of grams gives me moles. Oh, you don't like it because it's not written like that right above it in blue. But it is. It's just upside down, right? There's 1 mole of the SRSO4 for how many grams? It's 183.69. Hook me up with an answer. It's going to be small. 6 times 3 is 18.3, 0.03, 0.03. Give me a couple more. And now it's mole. And that one is actual. Can you remind me how I know it's actual? It said in the question 6.543 grams were actually produced, correct? Well, you can write it in grams or moles, and it's still the actually produced chemical. So I need the percent yield calculation with the units matching so they can cancel. Don't do grams over grams because then you're going to have to do one more calculation. I got the 2 moles right now. Let's use that. Percent. That's not a percent. Yield equals 0.0356198 over 0.1234. Is that right? And that was moles over moles. What happens to those? They better cancel. Percents don't have units. And this looks like 25%, a little higher, maybe 30%. So 28.65% if you multiply by 100. 87% yield. That's better than I thought. I said it might be a ridiculously low one. It is kind of low, but there you go. So that's good. And you'll see a practice exam question just like this one. It is. It's there. And use this as your guide to do that one. I think we should do a combustion one again now so that we can do our combustion. In fact, what I'm going to do on that one is I'm going to copy the combustion one from the study guide, but change the molecule and its formula, and that changes everything. And that's how I do these questions. Ready to see it in the next video? Stop and end.